Hello friends, this is Dr. Antoine, your coach in data analysis using R2. In this video, I'm going to show you how you can use a statistical test to detect whether or not voters have changed their vote intention after following presidential debates. For instance, I will show you how you can use tests so as to detect whether or not voters have changed their intention votes after following presidential debates or meetings. As far as election is concerned, I take this occasion to congratulate the new elected president of Kenya, His Excellency William Ruto, and all Kenyans for having chosen peacefully and faithfully ideas and good programs presented by the president. This is a good example to be followed by voters all over the world. Okay, friends, just a message of congratulations because I'm going to show you this example at the end of elections in Kenya. Now, suppose that, friends, we have this situation. Before presidential debates, it was predicted that the percentage of registered voters in favor of various candidates to be as follows. For instance, for William, it was slated to have, it was predicted that he will get this percentage, Raila this percentage, David this percentage, and George this percentage. This is an example to show you how you can use the statistical test to test whether voters have changed the intention after following presidential debate. These are predictions based on maybe for members or the followers. Now, suppose that after presidential debate, a random of 2,000 voters were asked to show their vote intention, and the results are as follows. For instance, this value 1,040 were in favor of William, 580 for Raila, 240 for David, and 140 for George. Suppose that these are the results of our survey after presidential debates. Now the question is, when we consider these results from our survey, did the voters change the intention vote when we compare the predicted votes and after presidential debate? Now, friends, this we are asked to show whether or not there is a change in the proportion before presidential debate and after presidential debates. Now, friends, let's show let's first. Now let's record these results, these predictions. These are the predictions, and these are the candidates. Now I'm going just to create a data and to save this in R. Now I just create a table where I show each candidate and his name. Now these are the results of this comment. Now you see under each presidential candidate there is his expected percentage. As you can see here, this command allows me to indicate each candidate with his expected votes or percentage of voters. Now, as you see, this is the comment. Let's visualize these results. Now you see. So okay, friends, after showing that these recordings, after showing this recording, let's plot the predictions. This is the comment for plotting the predictions. Now, as you see here, William seems to be the first, and the next Raila. This is this is just an example. It is not the reality. Maybe the reality is something else. And what is next? What is next is to analyze the results of our survey. As you can see here, we have 1,040 for William. This is after presidential debates. 580 for Raila, 240 for David, and 140 for George. This is an example, it is not the reality. Now I'm going to do the same to indicate under each candidate, presidential candidate, its intention votes. Okay, now I can just show you the results. Now this is like what I have done before. And here I can calculate the percentage. I can calculate the percentage based on our survey. Now, as you see, friends, here from our survey, this is an example. William has 0.52, Raila 0.29, David 0.12, George 0.07. I can also plot these results so as to visualize. Now let's visualize and you can see it. Now you see this is the graphic after of our survey. And now, friends, the null hypothesis is that there is no significant difference between the observed and the expected values. That means there is no change, even though presidential candidates have expanded the project, the ideas. The null hypothesis is that there is no change between predicted values and observed values. Observed values are those values we have after our survey. This is the null hypothesis. Now, we are to test whether there is a significant difference or not. We are going to use the chi-square goodness of fit test and consider significance level of 5%. When the p-value is less than 5%, we are going to reject the null hypothesis that there is no significant difference between the observed and the expected values. However, when the p-value is greater than 5%, the null hypothesis will not be rejected, and we conclude that there is no significant change. We conclude that there is no significant difference between the observed and the expected value. Now, friends, I'm going to use this test, chi-square test, and these are our observed values. These values, this one, these values, these values, these are observed, and then there is predicted. These are predicted values. These predictions we had from registration. These values. Now let's run the test and we will see the results. Let's run these comments. Now let's print the results here. As you can see, friends, here, this is, let's delete all this. I run this comment. Let's run this comment. The comment is this. This is our observed value, and these are our predictions. And now let's print the result of the test, chi-square test. Chi-square the test for given probabilities. Now you see this is the test, and this is the p-value. Let's show you how we can see our values. I write options, skip n, so skip n equal 999. Now Let's run this command, print the result. Now you can see, friends, this probability of making error is too low. This is the p-value, the probability that our results are based on the error, it is too low. Now, we can, from our significance level, as the p-value is less than 5%, we automatically reject the null hypothesis and say that there is significant change between observed values and predicted values. Now, we look here, friends. Here, observed value are these ones. Observed value are these ones. But when you look expected value, if there were no change, what would have been the values? This comment, this comment, this one, observed, expected, sorry, this is expected. If there were no change after presidential debates, William would have 960, Laila 700, David 240, George 100. This is the expectations if there were no change. But when you look at observed value, you see now here observed value are different from expected, because here, for instance, William observed is 1040, while it would have been 960. Laila is 580, while it would have been 700. David is 240, there's no change, but in George there is only 100, expected is only 100, while there is 140. That means there are some candidates who were behind Laila, who voted maybe for William and for George. Yeah, for George. Yeah, because George observed the value in this our survey, we observed the value are higher than predicted. And that is how you can test statistically if there is a change in our predicted value and our observed value. This chi-square test also be used to compare if there is any statistically significant difference in values. We can also test it using, suppose let's create a data and I will see if there is a significant difference between these values, this value. I want to see if there is significant difference between these values, and the null hypothesis is that there is no significant difference in our values. Let's see, friends, here, and I run the same test, chi-square test. It is these tests on my data. I want to see if there is significant difference on. I want to see if there is a significant difference between these values. There is a significant difference. Now, the p-value, as you can see here, friends, the p-value is less than 5%, and they conclude that there is a statistically significant difference in our values. Okay, friends, now you can see how you can use chi-square test so as to test whether there's a significant difference in our predicted values and in our observed values. Okay, friends, I hope this test can be, this video can help you to increase the knowledge in data analysis, and I show you how you can apply this test to analyze whether there is statistically significant difference between your expected values and observed values. Okay friends, if you like this video, you can share it, and I invite you to subscribe to my channel so not to miss the next video on data analysis. And I remind you that our channel make presentations on various subject areas like decision-making models, like data analysis, entrepreneurship, and also in other domain. And you can watch our videos. Thank you very much for watching this video. For next video, bye.